the previous video, we kind of went through the basics of how to use ChemDraw to draw a structure. And I wanted to show you guys a little bit more of what's going on behind the scenes and some of the other features that ChemDraw does have. Now, if you remember last time, we drew benzoic acid, right? So we drew benzoic acid, we did this, right? Added some bonds, double bond, put some oxygens, and we ended up with this here, okay? And that's fine. But there's another feature that ChemDraw has that makes things a little bit easier for us. So if we go up here to structure and convert name to structure, it's going to bring up this window. So let's type in benzoic acid and hit OK. Ta-da! All right, so behind the scenes, this program has access to a database where IUPAC names and some common names are loaded in. So we can just type in the name of something, and automatically loads the structure. So I think, let's try this on the aspirin. Ta-da! Right, I type in aspirin, it says, oh, I know that's supposed to be, acetyl salicylic acid, right? So there it is. And it even has some abbreviations. If we type in something like MCPBA, it says, okay, I know what they really talk about is metachloroperoxybenzoic acid. So you can convert name to structure, right? You can copy and paste an IUPAC name in there, some common names, and it'll just automatically pull up that structure for you guys. And you can actually go in the other direction too. Let's see here. Let me erase this for just a minute. If I'm expertly drawing something, right, let's just go with this. All right, so I've got that guy right there. And I say, oh man, I forgot my naming rules. What is that? I can select my structure, right? Select my structure. Go up here, convert structure to name. And it's going to say, all right, following IUPAC rules, this is 2-methylpentane. Okay. Let's erase the name for just a second. And let's look at this guy instead and say, all right, well, what's the name of this? R2-chloropentane, right? So it's even going to do your RNS for you, cis and trans, this kind of things. So if you're having trouble with something, forget the name or how to name something, right? You can draw it in here, and you can tell it to predict the name for you there. Okay. So there we go. Something very useful. All right. Okay. Let's take a look at something else. So let's bring our aspirin back in. Right? And remember, you're going to be synthesizing this in one of the first labs, right? And you have to write a lab report about this, kind of what's going on and what happened in your lab, and do some analysis and things like that. Now, one of the analyses that we're asking you guys to do is NMR. So if you draw your structure, select it. If you go up here, take a look at what we have here. Predict proton NMR shifts and carbon NMR shifts. So I wonder what this does. Man, look at that. So it will predict an NMR for us. It's going to go through, right? It's going to label the different, where it thinks the different peaks should come from, right? You'll notice that there are some in blue, some are in red. That's just how good its prediction is, all right? So it's going to have an NMR down here. Say, boy, I really, this is an eye exam for me. Well, remember, you can just zoom in on this too, right? Using the same zoom tool that we talked about earlier. So you can kind of mouse over stuff and it'll highlight, right? Let me zoom out for just a second, right? If I mouse over this peak right here, so take a look right here, okay? As I mouse over this peak, it's going to highlight in green where that peak comes from, right? So you can highlight around here. It's going to be pretty helpful for you to kind of go through and figure out where that stuff is. Now pay attention though. The first time you do this NMR prediction, take a look at the bottom. It says protocol of the Proton Nmr Prediction. Library is just talking about right here where it is using the prediction tools from. So that's not too important for you. Solvent, CdCl3, deuterated chloroform. That's what we use in the lab. And right here it says 60 megahertz. Now understand that the instruments that we have in the teaching labs at least are only 40 megahertz, but 60 is the lowest that this software can predict with. Okay, so let me show you how to set this down here. If you go to File, you go to Preferences, you go to Chem NMR. So File, Preferences, Chem NMR. Here you can select your solvent between DMSO or deuterated chloroform, and you can set the frequency. right? I think we can go all the way up to 600 megahertz frequency, I believe is what it lets us go to. Okay, and then we can close that and ask it to predict the NMR again. And look how pretty this NMR is now, right? 600 megahertz. You can see this is beautiful splitting now. We can see exactly where each of these comes from, right? So this, the stronger the instrument, the better the NMR is going to be, so to speak. But probably the most useful for us is if we set this to 60, because that's going to approximate the closest that we can do in our lab, at least. Okay, whoops, I didn't mean to save that. All right. So draw your structure, structure to name, name to structure, predict NMR shifts here. That's going to help you guys kind of interpret your NMRs. All right. Now, I'm going to give you guys a strong word of caution. Okay. I'm giving you guys a very powerful tool here to help with NMRs. Now, understand that NMR is going to show up on your exams. Okay. And if you're only using this to solve your problems and you don't know how to actually interpret the NMR yourself, you're going to be losing points on the exam. So don't do that, right? This is here to help you guys out. And to help to understand NMR, which is a very difficult subject, but don't use this exclusively, right? This is here to help you guys out, not to be a catch-all for everything, all right? So in summary, we talked about structure to name, name to structure, NMR shifts, and the last thing that I wanted to cover with you real quick is, let's say you're not a nice artist, okay? Let's say that we have a not so great looking structure, right? So it's kind of, oops, I'm trying to purposely draw something that's not so pretty, so it's not the easiest. All right, so we got some weird bonds going all over the place, all right? If I select my structure and I go to, where is it here? Structure, the structure menu, clean up structure. Okay, ta-da, right? So the cleanup structure option is going to make your drawing look pretty, right? It's going to even out the bonds, going to spread things out to make it as easy to read as possible. Okay, so here, cleanup structure. All right, that's it for this one. We'll see you in the next video then.